Hi, CP Algebra 1, Mr. Stirrup here, and this is solving quadratic equations number 5. And we're going to go through this and see how we do. Hope all of you are doing well. I sure do miss you all. All right, so we are going to go ahead and start solving these. And so outside the radical and outside the radical can be multiplied together. So 4 times 3 is going to give me 12. And then inside the radical, 2 times 2 gives you 4. The nice thing is 4 is a perfect square. So if I take the square root of 4, I'm going to get 2. And so now that 2 is outside the radical, so I wind up with an overall answer of 24. There's no radical there. Not every time will the radical go away, and I think we'll see this on the next problem. Letter B, we're going to go ahead and treat this like FOIL. So I'm going to take negative 2 times 4 to get negative 8. And negative 2 times 15 gives me negative 2 root 15. And then I'm going to take the root 3 times 4, and that's going to give me 4 root 3. Realize the radical stays on the right side. And then if I multiply this last, that's inside to inside, so that's going to give me plus square root 45. Now we need to start looking for perfect squares. Well, this is going to stay as it is. 15 just breaks up to 3 times 5, so there's no perfect square, so that's going to stay just as the same. 4 root 3 won't break down any further either, which gives me 4 root 3. But then 45 actually breaks down to 9 times 5, and 9 is the biggest perfect square that goes in there. So the square root of 9 is 3, and then I get root 5. And none of my radicals are the same, so I can't add them together. I don't have any like terms, so that whole thing is my answer. The order of those is not really important. It's just as long as the sign preceding the number or radical, or number and radical, stays the same. Okay, next one we're just going to distribute over. So we can multiply outside to outside. So 2 times 3 is 6, and then the root 2 comes along for it. And then 2 times 5 is 10. Now I think that answer is fine, but some people might want to have the answer like this. And I think they're both correct, but just be aware it can be written either way, just as long as the signs and the radicals stay together. Letter D is a little bit different, where this 2 comes here, n comes here. So 10 squared is 100, and then 2 squared is 4, and the square root of 4 is 2, so I get 100 times 2, which gives me 200. All right, so when we are adding and subtracting with radicals, if it's the exact same radical, we just count up. So 11 added to 3 is, or 3 added to 8 is 11. And then the root 2 stays just the same, and that problem's finished. Letter F, if we convert this 8, the 3 root 2 is going to stay as is, but the 8 converts down to 4 times 2, and we know what the square root of 4 is, right? The square root of 4 is 2. So 2 times that 6 becomes 12, and then I get 12 root 2. Now I have like terms. So I'm going to get 15 root 2 for an answer. This one we have to think about. 45 breaks down to 9 times 5. And this, so we have a square root. So square root of 9 is 3. So 9, or 3, that became a 3. I'm going to multiply it with that 5. So I get 15 outside. And I get square root 5 minus, and 20 is going to break down to 4 times 5, and 4 is the biggest perfect square in 20. So square root of 4 is going to be 2. That's going to multiply with that outside 2, so minus 4 root 5. Now I have like terms. They both have radical 5s. So I'm going to go 15 minus 4 is 11, so I get 11 root 5. Okay, so we have just worked this problem. So let's break this down into basic parts. So you know that's 9 times 5 minus 2 times 4 times 5. The square root of 9 is 3. So 3 times that 5 becomes 15. And then I have root 5 because I took the square root of 9 because that basically breaks down to square root of 9 and square root of 5. square root of 9 is 3, so I get 3 root 5, but I had that outside 5 is what's taking place to get that 15. Same thing with this next problem. I'm going to realize that that's going to be 4 root 4 times 5 times 2. I get 2 times 2 times root 5, so I get 4 root 5. Now I have like terms because they're the same radical, so 15 subtract 4 is 11, so I get 11 root 5. Hope you guys have been able to get outside and get a little sunshine. That's kind of help you out. All right, in this next page, let's see. Again, I'm going to distribute that here and here. So I get 4, and then I get square root 4. And I know square root of 4 is 2, so I would just get 8 for an answer. Bring that here and here, so I get 25 root 9, because 3 times 3 is 9. Square root of 9 is 3, so I get 25 times 3, which is 75. All right, so your homework is going to be SQE number 5, and I will have that as a page next. These are just a couple of sample problems that we can work on. Let's see what else we have. I think these are all of our problems that we could do. I think that would be SQE number 5. So if you go ahead and do each and every one of those and just do it on a separate sheet of paper, that should help you along for the quiz. Hey, I hope you all are doing great. So this is the problems below. So just go through and give them a try. And then remember, we have those Zoom meetings set up. And if you wanted to contact me, send me a text. Let me know who you are, and we'll set up a Zoom meeting, and I can send that out to everybody. So 720-273-8859 is my cell. Send me a text if you want to set up a Zoom meeting. Cool? Take care of one another. Have a great day. Bye-bye.